How's it going, ladies and gentlemen? It's Mr. Donahue here again. This time we're going to take a look at 5.6 problems. We're just going to cover Hess's law. So why don't we start with summarizing Hess's law? Basically, it's saying that if you take a look at the delta H's of each step, so if you take a look at delta H's of each step and add them together, you get the delta H overall. Right, that's a G. You get the delta H overall. So it's like saying, all right, well, if this was my starting point and this was my finish point, you know, there's a bunch of ways that you can go there, and it doesn't matter, because if we want the delta H, it's going to be the difference overall. So I could go, all right, in step 1, I can go here. Step 2, I can go here. Step 3, I can go here. And step 4, I can go up to there. And if I want the delta H overall, it's just going to be delta H of step 1 plus the delta H of step 2 plus the change in heat, the delta H for step 3, and add that to delta H of 4. And overall, you'll get the delta H overall. Okay? So, question, applying Hess's law. It says, what is the delta H for the reaction below if given these as our steps? So we have these as our steps and this as our overall. So they want to know, well, what is the delta H for that reaction? Well, this is how I suggest you guys solve these problems. Take a look at what you want to end up with. I want to end up with IF5 as a gas. So I'm going to look at the given equations to see if I can find IF5 in any of those equations. I can only find it in one place, which is great because that tells me that I know exactly what I'm going to have to do with this. All right, well, IF5 only shows up as a product in the second equation, but I need it as a reactant. So I'm going to have to flip this. So I'm going to have to flip this, which means that sign is going to become a positive. It was negative 745, but because I'm going to flip it, I get a positive 745. So what this reaction is going to be, is I'm going to get IF5 gas becoming IF gas and 2F2, which is also a gas. So now this equation is no more. I flipped it around. This is the new delta H. And now let's see. IF3 I need as a product. Hey, it's as a product in this equation, and it's the only place IF3 shows up. So that tells me that I'm going to want to keep this one and not do anything to it. So hopefully now everything that shouldn't be there cancels out. For example, I have 2F2 as a product, but I only want 1F2. And hey, look, there's an F2 as a reactant in that first equation. So that's going to cancel out one of those F2s. And boom, now I'm left with only what I want. If I add everything together, I end up with my desired equation. IF5 becomes IF and F2. IF3, I'm sorry. Right? Boom. So add together, bada bing, bada boom. Bob's your uncle. I forgot the IF here cancels out the IF there. I'm sorry. All right, everything that shouldn't be there cancels out. So what does that mean? What do we have to do with the delta H's? Well, because I flipped it, I changed the sign, and because I didn't do anything to the first equation, I don't do anything. So now I just combine them. And when I combine them, I get a positive 355 kilojoules, which is going to be my answer. 26, given the following equations, what is the enthalpy of the reaction for the following reaction? So this is our desired. These are our given. So let me look. Is there anywhere that N2 shows up? There is only one place that N2 shows up. Perfect. So I know I'm going to have to mess with this equation to get N2 where I want it. But I don't even have to do anything because N2 is a reactant right there, and it is a reactant in my desired equation. So I'm just going to keep this how it is. I'm not going to do anything to it. So why don't I look for O2 now? All right, well, there's two places that O2 shows up, so maybe I'll look at the other thing. NO. Is there anywhere that NO gas shows up? There's only one place that NO gas shows up, so that's going to tell me I have to do something to this equation if I need to change it for NO. Well, I need NO as a product, and it is a reactant, so I'm going to have to flip this equation, which makes this negative 114.2 become a positive 114.2. And why don't I just rearrange this now since I flipped it? It's now going to be 2NO2 becoming 2NO and O2. So now hopefully everything that shouldn't be there cancels out. And let's take a look. All right, so I have N2. Let me add these together. I have my N2. So when I add them together, I end up with N2. Let's see, I have 2O2 And then I have one O2 on the opposite side, so that's going to cancel out one of those O2s. Boom. So now that gives me just O2. Any other reactants? Well, let's see. I got 2NO2 in my other equation, but it's going to get canceled out by the 2NO2 in the other equation, so that cancels out. I have no more reactants that I got to worry about. Let's take a look at my products. The only product that I have here left is the 2NO. So cool. It's given me everything that I wanted. I got my desired equation. So because I kept that first equation, I leave it how it is. I flip the second one, so I change the sign, and now I combine that. And I end up with a value of a positive 180.6 kilojoules. And that is my answer. Or 27, given the following. So I have two given equations, and again, I want this overall equation. Well, let's start looking. If this is what I want, I need 2 SO2. Do I see SO2 anywhere? I only see it right here. And that is good news for me because that's the only equation that has it. Then I know I have to do something to that equation. Well, I want 2 SO2s as a reactant. So I'm going to have to flip this one because the SO2s is a product in it, and I need to double it. So let me rewrite that. So I flip it, so it becomes SO2 becoming S and O2. And because I have to double it, I have to times everything by 2. So 2SO2 becomes 2S and 2O2, which means I also need to, all right, well, if I'm flipping this, the negative 297 becomes a positive 297. Then I have to times that by 2 because I'm doubling it. So I end up with a positive 594. Is that delta H? So I'm going to scribble this out so I don't get confused. And let's see, I need O2. All right, and I'm going to scribble out this equation because I'm not using it anymore. I flipped it. All right, O2 only shows up as, O2 shows up here and here. So maybe I want to look at my SO3. SO3 only shows up here, and I need 2 of it. And hey, there's 2 of it as a product, 2 of it as a product. So I don't have to do anything, hopefully, to that first equation. So now if I've done everything right, everything that should be there cancels out. So let's take a look. All right, all my reactants, I have 2 S's, and I have 2 S's here and there, reactant and product, so they cancel out. I have 3 O2. Well, hey, there's 3 here, but there's 2 on the opposite side. So 3 reactant, 2 product means 2 product cancel out, and I'm left with just 1 O2. Let's see, 2 SO2 doesn't get canceled out anywhere else, and that's all my reactants. So now my reactants will be the 2 SO2 and that remaining O2. And the only product that I have left from my equations up here is the 2 SO3. So cool. So now all I got to do is combine. I have a negative 790 from the first equation that I didn't do anything to, and I have a positive 594 from the second equation that I had to flip and double. So then I add them together and I get a negative 196 kilojoules. And that's how you do that. All right, one more. 28. What is the enthalpy change for the following reaction, given the following information? So again, I'm going to look. All right, do I see NO anywhere? Well, I see NO in this equation. I see NO in that equation. I'm not going to start with that. I'm going to start with something that only starts in one of those given equations. NO2. All right, let's see. I got NO2. This is the only place that NO2 shows up. So I'm going to be able to figure out what I got to do with that equation. Well, I have 2NO2 as a product, and in that equation, 2NO2. So it looks like I'm not going to have to do anything to that. I just got to keep it. All right, what about N2? N2 only shows up in that first equation. And if it's in the product of what I need, but it's in the reactant of what is given, that tells me I'm going to have to flip it. So that positive value is going to become a negative value. And this equation is going to get flipped around. So I'm going to rewrite that below it. All right, so it flips around. I end up with 2NO becoming, I'm going to write that arrow there, becoming N2 and O2. All right, so now hopefully when I combine this, everything that shouldn't be there will cancel out. Well, let's see. I got O2 as a reactant, O2 as a product. They cancel out. Anything else cancel out? Nope. So hopefully when I combine all this, well, let's see. I got 2NO and 2NO, so I end up with 4NO. And that's all my reactants becoming N2 and 2NO2, right? I got the N2 here, the 2NO2 there, And hey, it's the same thing as what I'm trying to get, so perfect. So now I just got to combine these equations. I have a negative 180.7 kilojoules because I had to flip that first equation. I have a negative 113.1 kilojoules because I didn't have to do anything to that equation. And then I combine them and I get a negative 293.8 kilojoules. And that's how you do that. All right. So I hope you found that helpful and see you in class. Okay, bye.